This is David Hamaker in EECE 237, and this is my final project. I'll be using a soil moisture sensor, and with that I'll be using my ESP32, which will go into low power mode and then wake up, ideally every 24 hours. And it'll wake up and it'll take a reading on how wet the soil is, and it'll save that data to an SD card, which I can then process and determine how long it will be in between waterings for any given plant with this moisture sensor in it. So to create this program, I use the low power mode, or the light sleep example. I also use the ADC single read, as well as the SPY or SD SPY example, and I combined all those codes to make this kind of happen here. So first of all, I set everything up here. Well, I got my moisture sensor there, and it's from SparkFun, and it's a ADC, so it just puts out a reading if it is 0, or if it's completely dry, the reading is 0, and if it is completely saturated, it is about 4095. And we just set that up there to an ADC pin. I also have this SD card there, and I have those set to, I have the MOSI set to GPIO 15, the MISO to GPIO 9, the clock to 14, and the CS to 10. So I have those all there and hooked up with these colorful wires there. And this white wire is attached to a 1 ohm resistor there before going to ground, and that was for power management reasons, and we'll talk about that in a little bit. So here I have a damp washcloth. It's wet on one side, dry on the other, and we'll see if we can get some interesting readings here. But instead of taking one every 24 hours, I actually have it set up to take a reading every 2 seconds, so we don't need to wait that long. So here's how this will work. I'll set that on this wet part, and we will flash there. So I have the sensor in the wet part of the washcloth there. I'm going to jump it out, put it in a more dry part, and jump it out, put it in an even drier part, and then a really dry part, and let's put the real wet part back on. There we go. Alright, we'll stop the reading there. As you can see, it's still going on and off. And get that SD card out. And there's the data. There's the raw part. Yep, you can see where we take it out and put it into a drier spot, and then take it out entirely at the end there. So let's import this file. Oop, there's some old data. Let's get rid of that there. And replace it with this new data. Okay, there we go. After a quick refresh, we got it going. And you can see there it's going up and down, 100% saturated, and then almost completely saturated. And this is on a scale of 100% to 0%. I weight that in there, so you can get all sorts of interesting data, and you can see how long in a real plant it would go from 100%, then gradually down to 0% as far as how moist it is. It's a little tricky to get any decent data with the washcloth method, but it's the best we got unless we want to wait, hours and hours for something to dry out. But that's it. And so when it's in low power mode, it pulls 1.8 milliamps, and when it does a measurement and reads the SD card, it jumps up to 6.9 milliamps. And so with the calculations being what they are, over the course of 12 hours, it's really on for like barely 1% of the time. So it's like 1.8 milliamps is what is drawn over any particular time there. Actually, when we look at the battery and we compare there, it looks like it's gonna last about 64 days there. And even if you take it 24 hours, it is a similar calculation, and you don't really eke out much more power. So I would probably say that this would last about 2 months before you would need a battery change, just to be on the safe side. And this is even just assuming that when I read it, it takes less than 1 second to do a reading, but this is assuming 2 seconds. But over the course of 12 to 24 hours, it's so negligible that it's really almost always in low power mode. So there it is.